In this video, I'm going to talk about lean management and discuss some of the processes that are applied in order for businesses to become lean, and look at the characteristics of those processes and see what the benefits and the downsides of the processes are. So to start, we're essentially talking about a pull system through the value stream. Now, the value stream is created by the business. This is the transformation of inputs into outputs. That's, if you like, the production process. The pull system means it's customers at the final end who are pulling the production through the system. It's customer orders that are driving the system. So it's not being pushed. It's not management deciding to make certain amounts of different items and store them away in the stores in batch productions to meet orders when they come in the future, in anticipation of orders. That's more a push system. Management is pushing the work through the factory, through the system. So pull is fundamentally different. Pull is when customers at the end are pulling the work through the system. It's customer orders that must be completed that's driving the system. So it's a pull system. A way to capitalize on the increasing strategic importance of fast response to the customer is to minimize all the lead times. So if the lead times are reduced, then the response to customer orders will be much faster. So try to cut out waiting and lead times and enable a more efficient pull system to operate through the factory, if you like, or through the system. The pull system, as I said earlier, is where customers place an order for, let's say, 50 of the items, and these 50 will be produced. Not 60, not 70, nothing for stock. They produce 50. Because that's what the order was. And that's the most efficient level of production that meets the customer's requirements. And because it's precisely what the customer required, it means there is less waiting time. There's less hold-ups in the system. And there's no arbitrary figure imposed by management to say that the order was 50, so let's produce 100 just in case. There is no just in case. The order was for, let's say, 50, 50 will be produced. As opposed to the materials requirement planning, a different idea about production and operations management, and the view that operations management take on the production process. Now, the material requirement planning approach of pushing material through the plant. As I said, lean enterprises rely on pull systems, whereby actual customer demand drives the production process. Push is when management decide to produce some extra items. They may think it's worthwhile to have them in stock, or it's prudent, or they may have some objective. But essentially, that type of production is pushed. And in a sense, it may go nowhere. It may be produced, held in stock, and never sold. No demand. Or it might be sold in the future sometime, and it's been in the store for a long time. It's had resources tied up in the product, raw materials, labor, machine time. The cost of the raw materials, the cost of the labor, all of that has been tied up, waiting for the sales. So the pull system is seen as much more effective. The customers pull the orders through the system. A pull system is a control-based system that signals the requirement for parts as they are needed in reality. They are not imagined orders. They're not in the minds of the management. These are actual orders that are on the books now and require attention now. So the order is driving the production process. The raw materials, the stores, the machines, the production people, the line management, the operators on the shop floor, all of them should be focused on completing the order that's on the books now. And that's the essence of the pull system. Now, there are different parts to looking at the efficiency of lean management and how lean management works. And we're going to introduce a few topics which stand out in terms of the literature, at least, if not indeed the practice of how they're worked in real situations. So I'm going to get into a few different ideas about the operations, the detailed operations of lean management. And for the start, we can imagine sequential production systems. Let's say with two machines. Let's say one machine produces 63 units a day and the second machine produces 35 units a day. Therefore, the most that can be produced is 35 units a day. Because if machine B depends on machine A, machine B can only produce 35, then the excess production from A is just going to lie idle. So there is an issue about getting sequencing of machines worked out appropriately, that the right types of machines are put in line so that they follow logically and efficiently one from the next. Now, there's another system which is very popular and worth considering, and it's actually quite a straightforward system, but it sounds complex. And this is known as the Kanban process. Now, Kanban, it sounds, as I said, horrifically difficult, but in fact it's what I've got on the screen at the moment. Try to imagine a production system in which orders come in and they're written on small little cards, maybe just an order number, the date, the quantity required, and the particular job specification. So job CDE and require 20. So, and the date in which it arrives. So really that's all is required on this little card. And the card is put on a notice board. So if I put the cursor on the screen for a second, our notice board is over here. This is our notice board. And these are just areas in the factory, let's say, just areas in the factory. And this area here has a lot of empty bins. Just bins in which we would keep materials or components or whatever. Just bins. Ordinary everyday bins. And you can see here I've got five bins. So we've got empty bins, empty containers. And in the containers will also be the Kanbans. The Kanbans telling the operators what needs to go into the bin. Now, where our system is, as I said, is a very simplistic one we've got here. But let's move. Let's say we now get an order, or we get some orders. Let's say we got 3 orders. Well, 3 of the bins, the empty bins, are now going to be used. Previously, we had 5 bins empty. Now we've got 2. 3 of them are being used for the orders. And you can see our order board has changed as well. Now we've got order details over here. And we've got 3 orders. We know we've got 3 orders that have come in for this particular item, or these particular items. So we've got 3 orders in the system. And 3 orders are flagged up on the board. So there can't be any mistake about this. The orders are in place and the bins are put out into the order section. If you like, a different physical section of the building where the bins are just stacked. And these bins need attention. And the bins are empty except for a Kanban card, a card containing very basic information. When the order came in, what the order is for. So we got 3 orders now. Now the production system needs to, these orders need to be processed. So let's say the work in progress is 2. Or why not 3? We had 3 orders, so why not have the 3 orders in production? Well, maybe the orders are big and we don't have enough machines. Or perhaps a couple of the machines are broken down. Or there's something happened. Perhaps the orders are too big and we simply can't. So we can take in 2 into work in progress. Now you can see immediately here there's a message from management. There is something wrong. Those 3 should have really gone into production, ideally. But only 2 went into production. 1 was held back. But that's for management to look into. And that's for management to consider at a later stage. As far as we're concerned here, we've now got 2 bins with the Kanban cards requiring attention, and these are in work in progress, WIP. And it means that they've gone onto the shop floor, the appropriate manager has taken out the Kanban card and looked at what is required and is now tooling up the machines to produce this item. And when the item's produced, ideally it'll go into the container. If it's too big, they'll make provision for it to go someplace, and the container will go with them, will go with that particular job. So the container follows the job around. So there can't be any error here. It's too simple. Meanwhile, management know what's going on. They know there are 2 jobs in progress. There's 1 order still pending because they don't have enough capacity to take on the 3. That might signal up that they need to do something about their capacity, their ability to produce more. Now in the next stage, these work in progress ones, well, one of them's been completed, but the other one's still in work in progress. And in the meantime, if we go back to the previous screen for a second, here we have 2 empty containers and 1 order. Now we have 1 empty container, so we have had a new order come in. One of the work in progress has gone into completed stage, so that's now actually done. That's completed. We still have 2 in work in progress. One of them is almost finished because it's been there since back here at this stage. Now it's still in there. It's going to come out and go into the completed stage. In the meantime, a new order has been received. Now the completed one, which was over here in the completed section, that's no longer relevant. That Kanban is now free, and that container is now free because that work has now gone, let's say, to dispatch, and the paperwork will be taken over by dispatch and by the accounts section, and they will look for payment and distribution and so on. So that Kanban has now gone back into an empty container, and it's got an empty card inside, a card with nothing on it. So if anyone looks in the container, it doesn't mean anything, nothing to do. It's empty. But there is 1 order outstanding here. So there's 1 order outstanding and there's 2 in progress. And it could be that we receive an extra order and one of those items from work in progress goes into the completed stage. And the people working on these jobs simply look at the Kanban. They know exactly what's got to be made, and ideally, as I said, if it fits, it should go into the bin. And when it's finished, completed, it's in the completed stage, then it moves back and it's emptied or delivered to the logistics, to the dispatch. It's delivered to the customer. But the bin is emptied at some stage, and when the bin is emptied, it goes back as an empty container ready for the next cycle. So the Kanban process is very easy to follow, and it's very easy for management to see where work is in the system simply by looking at the board. If we look at the board, I'll just put the cursor onto the screen again. Here's our board over here, which could be held in one of the offices, or the production manager might hold a board. So we know we've got 2 orders outstanding, we've got 1 job being processed at the moment, and we've got 1 completed. And that completed one will now go for dispatch, and the bin, the physical bin that followed it round, that bin will go back to being an empty bin, go back to the storage section for the empty bins, and wait to be used again. So when an order comes in, an empty bin is taken, and the order details on a Kanban card, that's what we call the cards, Kanbans, the empty bin plus a Kanban telling the production people what to produce, when the order was received and what to produce. That will go in and it will become an order. Sorry, I've skipped forward. That'll become an order, and they will then deal with it. It'll go into production, work in progress, and eventually be completed. So that's, as I said, a very simple way of looking at production, and it's one that's very effective and one that's talked about a lot in the context of operations management. There's much more to it, by the way. I've given a very simplistic picture. In practice, there can be many more complications and many more issues, but the essence of what it is we've got on the screen right now, and that's what we need to know. Now, Kanban and just-in-time, JIT, can apply in services as well. Most of the techniques used in manufacturing to become lean are equally applicable in services. So, for example, trying to make defect-free operations, which is desirable. Try to make operations with good quality, no defects, no rejects. Flexible layouts where the system can be changed easily to accommodate new orders or new requirements. Minimal inventories, or in a very strict sense, no inventories. But perhaps a few items held in stock. It's a contradiction in what we're saying. In terms of just-in-time, there will be no inventories. There will be no stocks kept. Stocks are a waste of money, a waste of resources. But sometimes people hold some just in case, and that's the problem. It's human nature. We're afraid of breakdown. We're afraid of disaster. We have this notion inside us somewhere that we need to keep stocks just in case. We should have a program of preventative maintenance. We should maintain the machines even though they're not broken down. In other words, we should anticipate their breakdown and, if you like, fix them before the breakdown. Look for worn out parts and replace them. Look at the general condition of the machine and try to fix any parts that seem to need attention or will need attention shortly. Often when local governments change streetlights in the UK, when a streetlight stops working, they come to fix the streetlight, but they might also fix 20 streetlights on the road. And the reason why is because all of the lights were fixed at the same time in the past. Now one has gone, one has ceased to function. That means the rest are in a vulnerable position. So rather than be called out again, they go and fix, let's say, 20 or 30 of them straight away. And it's preventative maintenance. They are fixing them even though they're not broken. But they're anticipating that they will break down soon, they will cease to function because one of them has ceased to function. And they're all made available at the same time, so they've got the same lifespan. They should start to go soon. So in order to stop repeated calls and repeated people have to go many times to the same area, pick out heavy machinery and ladders and so on. Instead of doing that, they replaced the lot. Preventative maintenance. And advanced technologies. Sometimes the advanced technologies means that managers are able to produce items very quickly and very efficiently. Perhaps new machines, new dedicated machines can be bought in, and machines which don't perhaps require large amounts of setup time and effort and switching over. So much more modular and easier to use. And there may also be the advantage of standardized work methods, that in particular items, the production, the parts are very standardized. So it's easy perhaps to switch parts between one line of production and the next. That may be the case in some companies, particularly where companies make the same product but make different versions of the product. They might be able to use common parts. Now, this idea of pursue perfection. Well, 5 commonly used tools that lean organizations use to pursue perfection are the 5 S's. I'll talk about those in a second. The visual factory, Kaizen, talk about that again in a moment. Poka Yoke, talk about it again in a while. And total productive maintenance. So we'll talk about these. But 5 tools that may lead to the pursuit of perfection. 5 S's, the visual factory, Kaizen, Poka Yoke, and total productive maintenance. Let's start with the 5 S's. The 5 S's are to sort. Make sure that the items can be easily sorted. There may be facilities for sorting items that don't have to be done by hand. Perhaps it's more efficient to get a machine to sort the items and to count the items and lay them out in a fashion that are easily accessible for the next stage in production. So, sorting. Straighten. Set in order. Sometimes items have to be put into a certain sequence, which is it's like straightening. It's getting them into sequence. And again, that might be capable of automating that. It sounds like a standard thing to do. And if it's a standard thing to do, then a machine probably can be employed to do it and do it very efficiently and very fast. Scrub. Scrub is the same as shine. It means make sure that the whole area is clean and capable of being worked upon. There's no clutter, there's no distractions, and there's nothing to prohibit the use of the items further along the line. There's no defects as a result of a bad environment or a dirty environment. And systematize, which means get a system together, get the whole program of events that are required, get them sorted so they are logical and they are sequential, and there's no going back. There's no need to go back and revisit a previous stage. The various stages are logically set out, and once one stage is complete, it's complete. Just move on to the next stage, complete that, and move on. There's no need to revert back and get something right and do it again. It's done. And standardize. As far as possible, working with standardized products leads to greater efficiency. There's learning by doing. People become familiar with the size, the shape, and what's required from certain objects. So try to standardize them if possible. And it would be even better if they could be standardized across various lines of production. And as I said a few moments ago in a different context, if the company makes different versions of the same item, it may be that some of the components are the same, so there's greater opportunity for standardization and more economies as a consequence. So the 5 S's are in pursuit of perfection. And they include everything, as you can see, from sorting, straightening it out, getting everything ready for the next phase, cleaning up, making sure that the environment is appropriate, getting the items so that they're ready for production. There's nothing to hold up the production because they are unsuitable or in a state that's unsuitable. There's a system that runs logically. They don't have to go back and sort out previous stages. Everything is sorted and standardized if possible. The visual factory, that's another one of the pursue perfection tools. The visual factory, the objectives of the visual factory is to help make problems visible, help employees stay up to date on current operating conditions, and to communicate process improvement goals. So the visual factory it's trying to communicate where the current state of production is, what needs to be done, what's currently being produced, how are the resources being used right now. The visual factory, problems can be made visible through the use of charts displayed throughout the workplace that plot trends related to quality, on-time delivery performance, safety, machine breakdown, productivity, and so on. So it's a whole list of possible measures, performance measures if you like, which can be picked out. And these can be represented perhaps in terms of charts or trends, so it's visual. The people who need to know this can see the information and get it directly. They don't have to do any calculations. They don't have to think much about it. It's visual. It's in front of them. In a separate video we talk about dashboards, and we talk about the use of dashboards, which could be electronic real-time devices which will pick up information from different parts of the factory and display it visually on let's say on a laptop or on a big screen, so that the management can see easily what's happening and how production is varying minute by minute. Well, in the visual factory, this particular slide suggests that this could be just every week there could be performance measurements put up in the form of charts and pie charts and histograms and so on, showing where production took place, how far the production was off target or met the target or exceeded the target, and so it's a visual representation. I suppose it's really a short step from what I'm saying about the visual factory in the context of this slide to the dashboard idea, which is dealt in a separate video. The dashboard idea where it's electronic and it's updated by the moment. But it does critically depend on the availability of the information and the processing power of computers to take in the information, represent it in real time and present it and so on, and whether it's worth it. It depends on the size of the company and whether it deems that appropriate. But certainly the visual factory is a way of pursuing perfection, because the operators, the line management, the departmental heads, they can see where they're not performing to standard. They can see where they're falling short, and they can take remedial action to improve that. Now, this idea of Kaizen, Poka, Yoke, which sounds a little horrific. Well, Kaizen simply translates into continuous improvement. The idea of Kaizen is to continually search out improvements. It's not complacent. It does not rest on its laurels. It does not say, well, job well done, and sit back. This one is continually looking for improvements. And that's the idea behind Kaizen. That's what Kaizen is. It translates into continuous improvement. The goal of Poka Yoke is to mistake-proof work activities in a way that prevents errors from being committed in the first place. So Poka Yoke is making sure that mistakes cannot happen. It's doing its utmost to design the processes in a way that mistakes cannot happen. Mistakes are costly. They cost raw materials and labor and machine time and so on. And it's important that mistakes are avoided. So this idea of Poka Yoke is to mistake-proof work. So that mistakes are, if they cannot happen, then they're certainly extremely unlikely. But ideally, the search for continuous improvement, the Kaizen idea, search for continuous improvement, and through this Poka Yoke to find methods of production which are mistake proof. So there are no mistakes. Mistakes can be particularly costly if they're towards the end of the production line. A mistake at the final stage may mean the whole job has to run from the start again. And that's very expensive. So it's important that all of the work is thought through completely. The total productive maintenance is another commonly used tool that lean organizations use to pursue perfection. Now, total productive maintenance, equipment impact waste on a number of ways, including, now this impacts on waste in a number of ways. It's looking at equipment, it's looking at the total productive maintenance, and it's looking at the impact of breakdown of machines and hold-ups in production caused by poor maintenance. So if the equipment is not properly maintained, it leads to breakdowns, and then the machine has to be reset. So there's setup costs. And there's the stoppage, just simply the waiting around while the machine is down, holding up perhaps the next machine in line. If it's sequential, if the production flows from one machine to the next one is going to stop as well, waiting for the machine to start up. And it might run at reduced speed. Even if it doesn't break down, the machine may be unreliable and have intermittent stoppages, and so overall it's running at a reduced speed. Not ideal, it's not very efficient. And the yields on the machine are less. It produces less, so the return on the machine is less. So all sorts of indicators, financial ones, returns on investment, all sorts of indicators, performance indicators, will be thrown out by this waste. Now, the key components of a total productive maintenance program include identifying ways to maximize equipment effectiveness. So it's important that management, including the operations management and the line management and even the operators who have expert knowledge of the use of the machine, they should be involved in discussions about ways to maximize the equipment's effectiveness. And coordinating the work of engineering, operations and maintenance employees. The idea is that the work should be done, and in terms of maintenance, it should be done in a way that minimizes its impact on the rest of the business. So it may be, for example, the maintenance is done in the evening when the rest of the work is closed down, or it's done at weekends, or it's done at a period when there's no production taking place. It's giving employees the responsibility to maintain the equipment they operate. That's simply a good idea. The person operating the machine has expert knowledge of the vagaries of the machine, the way the machine works. So if the person is trained in health and safety and that's a part of their role, they may be able to close the machine down and fix minor parts that may be going wrong. Tools are wearing out, so they're able to retool the machine and in that way get it running faster and get it back online quicker. So total productive maintenance is a plan that tries to keep the machines running by scrutinizing the machines on a regular basis by taking comments from people who work with the machines, and may also involve preventative maintenance. If the machine is likely to break down, or they think it's about to break down, instead of waiting for the chaos when it does, they preempt it, and in a slack period of production, or in a period where there's no production, let's say at a weekend or something of this nature, they maintain the machine, and they completely overhaul the machine and fix it and get it back online, get it running properly. So that's the idea behind total productive maintenance. Now, the benefits of the lean organization. Well, 5 primary types of benefits can be identified. First one, cost savings. If it's lean, it's not spending time and effort on processes that are unnecessary. It's cut out all of the unnecessary parts of its activities. It's only concentrating on its core activities. What is absolutely essential, what must be done. They must be done on time, and they must be done properly, efficiently, and to good quality. Everything else can be cut. Revenue increases because the quality of the product is seen as higher, and it's delivered faster to the customer. So it's a good quality service, and the product is held in high esteem by the customer. So revenue may increase. There are also investment savings because the company is able to focus in on certain machines that are most appropriate for the core activities that they have identified, and other machines which are doing other jobs, low priority jobs or whatever, they may be removed, and those jobs could be outsourced if they were still required. So there are investment savings. And workforce improvements. Since the workforce are focused in on the core activities of the business, they have more expertise. They're not distracted by other activities which are not central to the organization, not strictly required, and therefore not necessary. Those activities have been cut, so now the workforce focuses in on the core activity, builds up an expertise in the core activity, and the workforce is therefore more suitable to that type of work. They're more efficient. And uncovering problems is part and parcel of this focus in on the core activity. The people who work with the machines or work with the processes that are involved, as I said, have an expert knowledge of these. They build it up over time. They build up a picture in their minds about the process. They understand the process. They've conceptualized it as well as doing it in practice. And they understand. So when problems arise, they have a better chance of identifying and diagnosing the problem. They identify where the problem is, they're able to deal with the problem, and they're able to pinpoint exactly what went wrong and also make recommendations to avoid it in the future. It's a much more controlled system because it's much more focused. And those are the benefits of lean production, or some of the benefits of lean production, which have been identified in the literature. So in this class we've talked about different aspects of lean management and different approaches to it and some of the issues. And that's all I'm going to deal with in this session, so I'm going to leave it at that and say thank you for watching.